Hi, I'm Chelsea Giltidones. I'm going to discuss about multiplexing. So, what is a multiplexing? It is a one-of-a-kind technique for combining multiple signals like analog as well as digital into one signal over a channel. This technique is applicable in telecommunications as well as computer networks. So, what is its history? In the year 1870, the multiplexing technique is invented first in the telegraphy, and at present, it is extensively used in communications. Scientist George Owen Squire was the one who recognized the growth of multiplexing in telephony in the year 1910. The signal, which is multiplexed, will be transmitted over a cable or channel and separates the channel into numerous logic signals. So what is a multiplexing? It is a way of transmitting various signals over a media or single line. Provides both privacy and efficiency. That entire process can be done using a device, namely MUX or multiplexer, and the main function of this device is to unite input lines for generating a single output line. A device is called the multiplexer is used at the receiving end, which divides signal into its component signals. So what's the difference between multiplexer and demultiplexer? Multiplexer combines the input signals into one signal. Meanwhile, the multiplexer is used when the multiplex signal needs to be separated into its component signals. A device called the multiplexer or the MUX is used. So there are three types of multiplexing techniques. First is frequency division multiplexing, FDM, wavelength division multiplexing, WDM, time division multiplexing, TDM. And under this TDM, we have synchronous TDM and asynchronous TDM. So this is the family branch or chart of multiplexing. So on the left side, we have the analog, and on the right side, we have digital. Under analog, we have frequency division multiplexing, FDM, and wavelength division multiplexing, WDM. On the digital side, we have time division multiplexing, TDM, and below that, we have the synchronous and asynchronous TDM. So what is FDM, or frequency division multiplexing? FDM is used in telephone companies in the 20th century in long-distance connections for multiplexing number of voice signals using a system like a coaxial cable. For small distances, low-loss cables were utilized for different systems such as belt systems, K&N carrier. However, they don't let huge bandwidths. This analog multiplexing is used to unite analog signals. This type of multiplexing is useful when the link's bandwidth is better than the united bandwidth of the transmitted signals. So to hold the adapted signal, the carrier frequencies are divided by sufficient bandwidth, and these ranges of bandwidths are the channels to different traveling signals. This can be divided by bandwidth, which is not used. The best example of FDM comprises signal transmission in TV and radio. So as you can see in this chart, we have two signals, signal 1 and signal 2. And here we could see the modulated signal of the two signals. So this is the frequency division multiplexing. So this is how it works. So as you can see here, it is multiplexed, and on this side, it was demultiplexed. Wavelength division multiplexing, WDM. In wavelength division multiplexing, the communication channel is a fiber optic cable. Wavelength division multiplexing is also known as WDM, and the multiplexer at the receiver end separates the optical signal wavelengths or colors. So in this technique, the bandwidth of the communication channel should be greater than the combined bandwidth of individual signals. The wavelength division multiplexing divides the bandwidth of a channel into several logical sub-channels according to its wavelength. It allows each logical sub-channel for a different light, color, or optical signal wavelength. The individual signals are filtered and then modulated to fit exactly to the logical sub-channels. This technique, each logical sub-channels allotted to each user is allotted to each user. In other words, each user owns a sub-channel. The main advantage of this WDM system is that you only need to upgrade the multiplexer and the multiplexer at each end. You don't have to buy more fibers, which would be more costly. Wavelength division multiplexing enables bidirectional communication and multiplication of optical signal capacity. How does WDM works? So the demultiplex signals are transmitted over sync communication as what we have mentioned before a while ago. So at the receiver end, the multiplex signals are separated by using a device called a multiplexer. The separated signal are then sent to the respective receiver. So under this wavelength division multiplexing, we have WDM. We have dense wavelength division multiplexing and coarse wavelength division multiplexing. So DWDM is a technology in which a large number of optical signals, laser light of different wavelengths or colors are combined into one signal and is transmitted over the communication channel to a long distance. Therefore, very small wavelength spacing is needed between two optical signals to put a large number of optical signals into the gain bandwidth. This technology uses this gain bandwidth to effectively transmit a large number of optical signals simultaneously. DWDM has the ability to transmit up to 80 channels, 80 optical signals with 100 GHz spacing. Coarse wavelength division multiplexing is a technology in which multiple optical signals of different wavelengths or colors are combined into one signal and is transmitted over the communication channel for a short distance. Coarse wavelength division multiplexing is simply referred to as CWDM. So this CWDM has the ability to transport 18 optical signals per optical fiber. It is designed for short distance. So what are the advantages of wavelength division multiplexing? First, WDM allows transmission of data in two directions simultaneously. Second, it is low cost. 3, it has greater transmission capacity. It has high security. And lastly, long distance communication with low signal loss. So this is the signal flow in wavelength division multiplexing. And this another illustration. So now we are in time division multiplexing. So time division multiplexing or TDM is a technique in which multiple signals are combined and transmitted one after the another on the same communication channel. So at the receiver side, the signals are separated and received. Each signal is received by a user at a different time. Time division multiplexing is simply referred as TDM. It is digital multiplexing technique. In frequency division multiplexing, all signals of different frequencies are transmitted simultaneously. But in time division multiplexing, all signals operate with the same frequency are transmitted at different times. In frequency division multiplexing, the sharing of a channel is done on the basis of frequency, but in time division multiplexing, the sharing of a channel is done on the basis of time. In TDM, each user is allotted a particular time interval called time slot during which data is transmitted. The time interval allotted to each receiver is so small that the receiver will not detect that some time was used to serve another receiver. In TDM, all signals are not transmitted simultaneously. Instead, they are transmitted one after another. For example, let's skip that example. The time division multiplexing technique is used to multiplex analog signals or digital signals. However, the time division multiplexing is more suitable for digital signal multiplexing. In time division multiplexing, the bandwidth capacity of the communication channel should be greater than the multiple input signals. So there are 4 types of TDM, aside from the two that I have mentioned a while ago. So we have synchronous TDM, asynchronous TDM, interleaving TDM, and statistical TDM. Synchronous TDM is very useful in both analog and digital signals. In this type of TDM, the connection of input is allied to a frame. For example, if there are n connections in the frame, then a frame will be separated into n time slots, and for every unit, each slot is assigned to every input line. In the sampling of synchronous TDM, the speed is similar to every signal as well as the sampling needs a clock signal at both ends of the sender and receiver. In this type of TDM, the multiplexer assigns a similar slot for each device at every time. Asynchronous TDM, for different signals, the rate of sampling is also different, and it does not need a general clock. If the device has nothing for transmitting, then the time slot is assigned to a new device. The design of a commutator, otherwise the commutator, is not easy and the bandwidth is low for this type of multiplexing. And it is applicable for not synchronous transmit from network. Interleaving TDM can be imagined like two speedy rotary switches on the multiplexing and demultiplexing surface. These switches can be rotated and synchronized in reverse directions. Once the switch releases at the surface of multiplexer head of a connection, then it has the chance of sending a unit into the lane. Similarly, once the switch has released at the surface of the multiplexer ahead of a connection, a chance to receive a unit from the lane. This procedure is named interleaving. Statistical TDM is applicable to transmit different types of data simultaneously across a single cable. This is frequently used to handle data being transmitted through the network line, LAN, or WAN. The transmission of data can be done from the input devices, which are connected to networks like computers, fax machines, printers, etc. The statistical TDM can be used in the setting of telephone switchboards to control the calls. This type of multiplexing is comparable to dynamic bandwidth distribution, and a communication channel is separated into a random data stream number. So what are the advantages and disadvantages of TDM? So the advantages is, first, full bandwidth is utilized by user at a particular time. The time division multiplexing technique is more flexible than frequency division multiplexing. In time division multiplexing, the problem of crosstalk is very less. So, disadvantage of time division multiplexing. In TDM, synchronization is required. Applications of multiplexing. Multiple signals can be sent simultaneously over a single communication channel. Effective use of channel bandwidth. Multiplexing reduces cost. Multiplexing reduces circuit complexity. What are the applications of multiplexing? First, it is used for communication system. Second, computer memory. Third, telephone systems. Fourth, TV broadcasting. 5, telemetry. And lastly, multiplexing can be used for in satellites. So recall of what was discussed a while ago. This is the comparison table of FDM, WDM, and TDM. So for FDM, the communication channel is divided by frequency. For WDM, the communication channel is divided by wavelength. And lastly, for TDM, the communication channel is divided by time. FDM is for analog as well as WDM, and digital for TDM. For FDM, synchronization is not required as well as in WDM, but in TDM, synchronization is required. So both FDM and WDM requires complex circuitry at the transmitter and receiver. Meanwhile, in TDM, it does not require complex circuitry. In FDM, the problem of crosstalk is severe. Same goes with WDM. In TDM, the problem of the crosstalk is not severe. The channel bandwidth in FDM is effectively used. The channel bandwidth in WDM is also effectively used, while the channel bandwidth in TDM is wasted. FDM stands for, of course, frequency division multiplexing. WDM stands for wavelength division multiplexing. And lastly, TDM for time division multiplexing. So that's all for my lecture in multiplexing. Thank you for listening.